before you dig into design pattern, I want to just like a 2-minute. What's your opinion on Oracle's approach? Actually, it's more confusing. Late cycle of licensing.
Okay, wow. Do I want to capture this on video? Sure, why not? So the question was, oh, Oracle's changed how it's releasing Java. What do you think? It's the nice thing about rapid releases is that it's really great for the developer. You get quick feedback, right? You know, Java had for like the last 10 years has been criticized for what seems like the glacial pace of change, right? Oh, we had to wait forever for generics. Oh, we had to wait forever for lambdas, and they were like, okay, no more waiting. They have all this stuff in the pipeline, and they're like, hey, as soon as var is ready, we're going to release it, right? It's like, hey, we've demonstrated that it's good. We've vetted it. Hey, it's not the most complex feature in the world. Yeah, we're going to release it. Okay. But on the same time, by the same token, they're like, we don't want to support 8 different versions of Java all at the same time. So they're like, okay, listen, either you're going to be on the old version that never changes, or you're going to be on the latest. We're not going to support in between. And I face the same thing at work, right? It's like, well, there's some customers that want the new features. They are they can handle the upgrades. They want to stay on top of things. They get security patches, to get new features, right? They want it. And then there are other customers who are like, hey, listen, if it ain't broke, if it ain't broke, don't try to fix it. We just want to keep it the same way here, but we want you to support it if we do find something wrong. So there's a balance. And so I think where Oracle is right now, I think works very well for some people. If you are, if you're working in the spirit of DevOps, where it's like, no, hey, you want to have, you always want to be up to date, and you want to be able to, enable rapid release, and so take advantage of new APIs, new stuff in Java. Great for them, right? And they probably have a continuous integration, continuous deployment pipeline where you just, twiddle, a bit. Oh, now use Java 11. Poof, and everything happens. Well, that's great for those customers. For the other users, and this is something that I even faced this term, where it's like, great, I want Java 10, and it's like, oh wow, look, Java 9, which was just fresh 6 months ago, right, is still out there and still the default on Ubuntu and everything like that. So I had to, take some extra steps. I guess I don't mind, but it does put the onus on us as Java developers to stay on top of things. Whereas before, it was like, great, yeah, hey, we can be Java. We can go pick up that book on Apache struts from 2004 and learn all. Or we can't do that anymore. It's okay. Yeah, good question. Okay, so I'm chuckling because I was really not expecting to do this. But what the heck? It's really hot. I just coded for like an hour and a half. And so let's talk about design patterns. So, wow, when I get to lecture, I never get to lecture anymore. And by the way, I've given this lecture exactly once, and it was in 2003. And so, luckily, the slide's still built. And so, it's going to be kind of rough, but we're not going to go more than an hour. And so, we're not going to get through all these slides. And that's okay, because it kind of reads like a phone book anyway. So, thank you to everyone who provided feedback on the first half of the course. Actually, I was really pleased with the quality of feedback that I got. It wasn't just like, your stuff's too hard. I mean, you guys were thoughtful, and I appreciate it. Of course, it does count for 4 points to your grade. But it was, but that was good. And one of the pieces of feedback that I got was, hey, I'd like to learn more about object-oriented programming. I'd learned to learn some more advanced stuff, there's functional programming stuff, but what about design patterns? It's like, and I read this morning, and I'm like, oh, I got a design patterns lecture. And so, okay. And so we're going to talk about that now. So object-oriented programming, one of the things that it really enabled and allowed people to really embrace was code reuse. Now, I mean, there have been every language has libraries or has intrinsics that, are in standards and stuff. So, I mean, code reuse isn't new, but I think one of the things that the object people, really glommed onto was the fact that you have these abstractions and you can reuse that abstraction in other places. So it's like, hey, we have a class that represents a phone call. Great, we're using it all over the place, right? And it's kind of nice because the abstraction hasn't changed, so we can use the same code. And so, I mean, object-oriented programming, like so many things started back in the 60s, but really sort of came into its own in the 80s, but you had a couple of camps, like the Smalltalk people that had sort of one view of object orientation. Then you had the C++ people that had another view of object orientation. But things kind of came to a head by the end of the decade, and so now we're talking about not exactly the time I was in your seats. It's a little bit before that. Well, actually, 1994 is when I started college, I suppose. But it's when, but people really started understanding object-oriented programming and code reuse, and there was this book that came out called, I'll go on the next slide, called Design Patterns, that really got everybody talking about, hey, here's ways that you can leverage object orientation to do some really neat things. So the whole idea is that they came up with these things called design patterns, which are ways of representing relationships between objects that can be reused in different circumstances. And they tried to create an analogy with building architecture in terms of reusing things like struts and supports, and here's how you design things. What it really gave us is sort of a language pattern language that we could use to describe things. So basically, the way this lecture is structured is that I'll talk a little bit, I'll do an introduction on design patterns, and then there's this whole catalog, really like a phone book, of design patterns in the book, and I'll talk about some of them here. The creational patterns, the structural, and behavioral. I'll probably only get sort of into the creational. So, if you want to design code for reuse, there's a balance that must be struck, right? It has to be specific enough to solve a problem, but it must be flexible enough to be reused in lots of different circumstances. And so, for years, you had these object frameworks that evolved to meet this, and you had languages, that had to add features, and people had to figure out how to leverage what was there in the language in order to provide, here again, frameworks that do something, but that are open enough so that you can extend them, so that you can customize them to suit your needs. And so, code reuse is good because you don't have to reinvent the wheel. But this is a thing that happens in all sorts of different practices. So, like in literature, we have the archetype of the tragic hero, right? So this is an archetype that has been used over and over again in all sorts of different circumstances. And what's really interesting when you look at these other things in other disciplines, very often people on the different sides of the world have the same idea at the same time, or even centuries apart, but it's all sort of the same thing, right? People arrive at these patterns. Oftentimes on their own. So you have patterns in literature, patterns in architecture. So you've got the blueprints, and if you're an architect, there are just certain tools of the trade. You pull this one out of your pocket. Oh right, I was building a house that was kind of like this one. It was on similar terrain, or they had similar requirements for it. I'll just reuse that over here. It's not exactly the same house, but it's the same following the same patterns. And the same thing in civil engineering when you're laying out a town. Lots of cities, just go to any suburb in California, are laid out the same way, right? Okay, yeah, you've got you've got the state highway, or in the Midwest, you got the state highway, and there someone's decided, okay, this is where you put the big box store, and then over here is the little strip mall, and then blah 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 blah. They follow these patterns. Well, in 1995. Eric Gama, Richard Helm, Ralph Johnson, and John Vlasides published their seminal work, which is Design Patterns, Elements for Reusable Object-Oriented Software. And what this did is it cataloged design patterns for object-oriented software. So you had OOP, you had object-oriented languages, and here are some catalogs for how to take advantage of object orientation to do neat things with objects, or as I call them, stupid object tricks. So one of the things that they had to do is figure out how they describe this pattern, because usually it's in code. And you don't want to put a whole bunch of code in there. You want to have a nomenclature, a way of describing it, and then also a way of cataloging it so that you can understand when you should use it and really kind of what it does. So every pattern has a name, and they've classified them into different classifications. It talks about, okay, well, what does the pattern do? Why would you want to use it? They try to, the patterns are meant to be applied. So they talk about, well, here's how you would use it, here's why you would use it, here are sort of situations where it would be good and situations where it would be not good. Then they describe what the pattern looks like. sort of at the high level, and then also describing what the participants, and we'll see what this means in a second, the class and the objects, how are they related, and what roles do they take on, what responsibilities do they have, how do they work together. And then each pattern then also has a little section that describes what are some of the consequences. Like, hey, if you follow this, you get these benefits. Oh, but you might be trading off other things when you apply this pattern. So, they thought about what should a pattern look like. So the Gang of Four came up with 3 categories of patterns. The first one is called creational. So there are patterns for when you create objects. We create objects all the time, and there are some patterns that you can follow when you need certain kinds of objects, and we'll see those. That's the one we'll focus on first, because I think that one is the sort of the most approachable. So for instance, there are patterns for saying, hey, listen, I want to delegate object creation to like a subclass or some other object. There are structural patterns which talk about how objects and classes are related. So things that how you can use inheritance to sort of compose classes together. When do you want to have delegation? How do you put objects that do different things together in a way that that sort of makes sense, or maybe has certain properties or exposes to certain behaviors. And then behavioral patterns that really talk about how responsibility can be distributed across multiple objects, and how to make sure that every object does something and does it well and doesn't do too much. So how to leverage object-oriented programming concepts like inheritance and delegation and virtual methods. What are those things called? Virtual methods. To perform some operation that no one object can carry out itself. So, this stuff isn't easy, and it involved with a lot of trial and error. So, the patterns really are the result of lots of experimentation and lots of adjusting of dials with regards to how data is encapsulated, how behavior is encapsulated, what where are objects coarse-grained, you can do lots of things. Fine-grained, only do a couple of things. How do you take into account performance, reusability, and how do you evolve the system? All sorts of good stuff like that. When designing these object systems, think about the nouns and the verbs that you're dealing with, right? You've probably heard before, the nouns become the classes, the verbs become the methods. But we're modeling things, and you need a nomenclature, and you need a vocabulary that is relevant to the problem that you're solving, relevant to the domain that you're solving, but yet can still be translated into code, into objects and methods and stuff. So, that's an important thing. You want to start with making sure that your system that your objects represents the system that you're looking to model. Now, the fact of life is that there are some things in either the language, or sometimes you have objects that don't really model a real thing, like an array. Right, there really is an array, and collections are kind of the same thing here too. So really what we're trying to do, what enables code reuse, is the proper abstractions. Right? So when you think about, hey, you're writing an API, well, do I really expose like an array of objects, or should I expose something like a list, or maybe there's like a node list or something that I have. And then there's some things that are abstractions and represented as objects that you wouldn't think necessarily because they're not nouns, but things like algorithms can be expressed as objects, and we might see, and there are patterns that leverage that to provide a lot of flexibility and a lot of good interface. Again, granularity. Another thing when modeling objects, I talk about this in like the object-oriented programming lecture. There's the concept of the interface, like, and in Java there's actually an interface type, but sort of like little I interface is the contract that you as an object provide. And here again, it's like here's my methods, my behavior, and each one of those methods, each one of those pieces of behavior have some input, have some outputs, and in Java they also have an exception that says, hey, here's what goes wrong. And as you're working with abstraction, when you're working with these patterns, very often the pattern says, well, I need an object with this interface, but then it's up to you, the user of my framework, the user of this pattern, to specify, well, exactly what an object with that interface does. And here again, we'll see that. So, one of my big mottos when it comes to object-oriented programming is that you program to the interface, not the implementation. So at the end of the day, just like you guys, right? So, the text dumper is a phone bill dumper, and so I hope there are places in your code where it's like, hey, listen, I just need some kind of phone bill dumper here. I don't care if it's a text dumper or if it's not, or more likely a collection, right? Hey, you just know that it's a bunch of phone bills, whether or not it's a sorted set or an array list, doesn't really matter, right? And as you saw, you probably evolved your code that way. So something like your like your pretty printer or your text dumper doesn't really care that the underlying data structure is an array list. It just cares that it's a collection of phone bills. Stuff like that. Okay. White box reuse versus black box reuse. So this is really doing stuff with objects. Now, when you have class inheritance, because a subclass has access to the private methods, the private functions, the protected methods of its parent, you're basically reusing all of that, and you have pretty good access to it, pretty good visibility into this. And because inheritance is defined in many languages, it's defined at compile time, it's static. It doesn't change over time. Now, there are object systems. There's this crazy language called self, which you can do things like change parents. It's actually a lot like JavaScript. Has anybody ever really studied object orientation in JavaScript? Like what it does? So not like what Prototype gives you, or not like what ECMAScript gives you, but 1994 style JavaScript. It is wacky. It is like all this object composition. You got the prototype object and everything like that. It's really cool, but it confused the hell out of people back in the 90s. There were only, literally 5% of JavaScript programmers really understood that. And then everybody else was just like, look, I can get blinky text. That's awesome, right? So, sorry, this is a digression. Back to compiled languages. You have white box reuse when you have static class inheritance. And this sort of, this comes with some consequences. So you can't change behavior at runtime. And if your parent changes, well, if your parent changes, you need to get recompiled to then get that code. Object composition, on the other hand, when you have one object that references or uses another object, this is like black box reuse. So basically, you have one object that uses another object, and they only interact through their interface. So the implementation of one can change, and the implementation of the implementation of the object being used by some client can change. The client doesn't need to know about it as long as the interface doesn't change. And this is important, right? Because here again, the internals of the object can change. You can use a different object. The client doesn't care because the client is just relying on the interface, and the interface doesn't change, then it doesn't know the difference. And what this allows you to do by using object composition is allow each object to be focused on one task. Again, do one thing and do it well. So, when designing object systems, the authors of the Gang of Four book recommend that you favor object composition over class inheritance because it's more dynamic and gives you a lot more possibilities. Have you guys ever talked about this stuff in any of your classes? Yeah, did she talk about this? Okay, good. So not entirely. It was a little bit, yeah. Okay, good. Okay. So one of the pattern is like a little P pattern. You see it a lot. Is delegation. So you've got some operation to do, some request, and it's implemented using two objects, where you've got one object that delegates some responsibility, some portion of the work to another object. It's like a child class invoking a method of its parent class, where it's like, okay, I'll do some stuff, and then I want to use this common behavior to do some more other stuff. But for delegation, things like this. Let's say you've got a window. The book really shows its age in places. And at the time, so like back in the mid-90s, where object orientation was used a lot was in windowing systems. Next, or the Athena widgets from MIT and stuff like that. Microsoft really hadn't gotten there yet. It was all still C code at that point. So a lot of these examples are UIs. And actually, this is really good because we can see a UI. We know what a window is. We know what a text box in it. You can imagine what it looks like to to render graphics and things like that. So in terms of the metaphor, I think it's a good one because it's one we're all familiar with, although it seems a little dated now. So let's say you're modeling a windowing system. So you've got a window object. And the window object needs to know its area, right? Its size. And so then what the window is in turn made up of multiple shapes. And one of those shapes would be a rectangle. And it knows how to get its area. So when the window needs to answer the question, what's my area? It delegates a portion of the work off to the shapes that it contains. It doesn't seem like rocket science, but this is sort of a fundamental concept in object orientation, that of delegation. And this is object composition because the window has a rectangle. The window itself is not a rectangle. It has multiple shapes, and here again, one of those could be a rectangle. And this is good because it lets you have lots of different shapes inside your window, and it lets you have different kinds of shapes inside your window, and yet you can get the area of all of them because here again they all those shapes have a get area method. Window could be circular. That's crazy. Anyway, so that's like object composition, a really good thing. You're going to see that a lot in design patterns. Another thing that you want to do is design your object systems, especially your frameworks, for change. So for things that might be different. Here again, this is all about usability. Usability has to balance. Reusability has to balance providing an expected set of functionality with the ability to do different things with that functionality. Some of the things that hinder evolution and redesign are things like having hard-coded class names. So a particular implementation of a function, the class name is hard-coded in there. In order to change that implementation, you have to go in and modify the source code of the thing that uses it. And there are patterns like abstract factory and the factory method, factory method, and prototype that delegate the responsibility of creating objects off to other ways so that there's not a hard-coded compile time dependency between them. Another thing that impedes reuse is depending on specific operations being executed in a specific order. And so a couple of the behavioral patterns are things like chain of responsibility and also the command pattern. And what this does is it represents sort of here are operations in a very abstract way so that you can change the operations depending on what needs to be done. Other things that abstract factory again is also good at addressing hardware or software specific designs. You abstract things like your let's say you want to have an application, actually this is very true of Java, that runs on both Windows and Linux. You can abstract out the specific implementation of a button or of a text box or whatever to the native platform, but then still have a lot of common code that just refers to that abstraction. And again, you can have an impediment to reuse is depending on specific representations of objects or implementations of objects. Again, very much like the hard-coded classes, where you can abstract out how an object is stored or where it lives. Right? You might have a remote object. Actually, we'll kind of see that in our GWT project, where the REST API, where the web server is abstracted out into a class. And so these things that are in italics here, I hope that shows up okay, are the names of various patterns in the book. Oh, and there's more. So more things that avoid redesign. Abstracting out your algorithms that you use. Tight coupling is just the bane of evolution. So when you've got two objects or two classes that are so intermingled, you can't tear them apart, which means you can't test them independently, which means that you can't reuse them independently, and this is bad. And so there's a whole bunch of patterns that help you distribute or it helps you decouple them so that they rely on a very limited interface. Yes?
You know, I agree that decoupling's great, but I've worked on projects where it's so over-engineered on the decoupling, like, oh, we want to, this works with Oracle, we want to make sure it works with SQL, so like, it's an Oracle shop.
Yep.
They will never change, I mean, like,
yep.
refactoring the project so that it can handle the database. Just go.
So yeah, I mean, so the question, I like with everything there is a balance, and the answer is always it depends. So and it depends a lot on the kind of software that you're building. So the design patterns book came out of object systems that were themselves frameworks that were meant to be reused. So again, there were a bunch of, think about like the JDK itself, right? Yep, it provides a lot of functionality, but it's also open to a lot of things. And so then the people that work on that, yeah, should apply these things. If there are certain parts of your system that don't need to be open for reuse, then you shouldn't implement them. Because exactly what you said, it can be, and I've seen this a lot in my career, it's really hard to approach when everything's a framework, when everything's a system, when everything's so abstracted. And I've done it myself, where I've been like, oh, I can add an abstract method here. Oh, I can add an interface, because these two classes have the same thing. It's like, well, do you really need that? So I have to admit, a lot of people, and I probably do this too, like, I read this book, I got all excited, it's like, great, I can use all these pieces parts. I'm like an architect, look at me and my blueprints, right? Overkill. So it's good to know, it's good to see, when you see it applied other places, it's good to understand. It'll give you a much better appreciation of the power of object-oriented programming, but you're right. It's not like you just sort of take these patterns and you say, okay, this one, plug it all together, poof, there's my software. It doesn't really work that way, because if you do that, all you get is sort of like an abstracted mess. And especially if you don't have good names for things, it's really hard to figure out what they all mean. So tight coupling is difficult. There are patterns that help you extend the functionality. So beyond subclassing, again, you've got ways of breaking up your object systems so that you can modify things very easily with changing a minimum amount of code. And yeah, those last two are pretty much are very related. So actually, things like adapter, decorator, and visitor are fun because they make it so that it really splits the responsibilities between something that does the work and then something that will ask something to do ask an object to do the work. So much fun. It's like we're visiting a whole bunch of friends I haven't talked to in 15 years. That's kind of sad. Okay, so now let's dive into some patterns. So we've done a half an hour of introduction. Now let's take a look at some patterns. Okay, creational patterns. These are patterns for creating objects. Now, we create objects all the time. Our systems are made out of objects, so you have to create them. But as we were talking about, the act of creation often leads to coupling. Right? I am instantiating that array list class directly, and so now my code must know that it's an array list at some point. And so now if I want to use a different, so now if a better array list comes around, I got to change all my things. I can't sort of rely on like, hey, give me something that stores objects in a specific order, right? If that's all I need. So. In order to add dynamicism to our systems, to be able to sort of decide at runtime, hey, exactly what kind of object should I use here? Actually, your example of a database was a good example. Whereas, like, hey, let's say I've got an application, I'm dealing with an SQL database. Depending on where it's being run, it might be Oracle, it might be SQL Server, it might be Postgres. I, as the author of the code, don't want to depend on that. I'm going to abstract that out instead. And in Java, you have something called JDBC, the Java Database Connector, that abstracts out all of the calls to the database. And so then at runtime or deployment time, that's when you will sort of wire it up and say, oh, okay, yep, it'll connect to this particular database, and this is an Oracle database, so please use what's called the Oracle driver to take the abstract API, the JDBC API, and implement that in a way that it will interact with the Oracle database. So what creational patterns do is that they encapsulate the information about what class is actually used at runtime will actually be used. And it hides a lot of the details about how the objects are actually created and assembled and stuff like that. Here again, it provides an interface over all of this behavior. It's all the patterns keep all of that there. And this gives you a lot of flexibility in terms of what is really composed when your application is run. Okay, here's the first pattern. But by the way, have you guys seen UML? Have you seen nomenclature like this? Let me just quick talk about it. So each one of these boxes down here represents a class or actually a class or an object. In this case, they're classes. The UML describes the methods here. So methods have parentheses on them. If they're italicized, they're abstract. And then there's inheritance. So the triangle arrows that point up are class inheritance. And then the non-triangle arrows is object composition. So one object uses another one. So, I have a UML lecture. Wow, I completely forgotten that. UML. Anyway, so the intent of the abstract factory is to basically you've got a bunch of objects that are related. But you want to but you've got a client of those classes, but the client doesn't care about the concrete implementation. They just care about some abstraction over it. So let's say that you have a user interface and you want to support multiple looks and feels. So like for instance, IntelliJ, right? It's got like the light mode and the dark mode. Okay, and so those widgets render themselves differently, depending on whether or not it's in light mode or dark mode. But but most of the code that interacts with those widgets doesn't care whether it's in light mode or dark mode. It just wants a button. It doesn't care what the background color is. Just give me a button. Okay. So this example, here again, a 90s example, where hey, you've got an application and you might want to have widgets that look good on a Mac or widgets that look good on Motif, on X. How do you implement this? Okay. Well, you've got a client. So this is the client. This is like your UI application. And it just cares about things like I've got a window, or I've got a scroll bar, or I've got a button, or whatever. And these objects that represent these UI widgets have certain properties. Oh, the scroll bar is 75% scroll. Oh, the window has a size. Oh, the button is pressed. That's all the abstraction that it cares about. Now at runtime, you need more. When you actually have that button, oh yeah, that's a button that knows how to render itself on a Macintosh. Great. Okay. Or you've got a button that knows how to render itself on X, on Motif. How do we represent this as objects? Well, the client deals with these abstract classes, like window and scroll bar, and it gets instances of classes that extend that abstract class through what called a factory object. So it asks for the factory object, and then it says, okay, create me a new scroll bar. Okay, create me a scroll bar. That's an abstract method, and the abstract widget factory is implemented for different, implemented differently based on whatever platform you're running on. So you start up your application on a Mac, and somehow something underneath the covers determines, oh look, I'm on a Mac. Okay, great. The widget factory that I want, that's going to be a Mac widget factory. And a Mac widget factory knows how to create a scroll bar for the Mac. It knows how to create a window for the Mac. But the client doesn't care. The client's like, give me the factory that I need. Okay, great. Now give me the scroll bar. Ooh, I've got a scroll bar. It doesn't care that it's running on a Mac. It doesn't care that it's running on Motif. So we've separated out responsibilities. We made the client, we provided an interface that gives the client just what it needs and no more. The client is completely happy because it has what it needs. And then we delegate all the responsibility for doing platform-independent stuff off to other classes. So that's the factory pattern. It's got some names of various things. So here again, it's got a factory. It's got abstract factories. It's got concrete factories here. And then it's also got abstract products and concrete products. So the factories over here on the left, like widget factory, and then the products are over there on the right, like window and scroll bar, and then concrete versions of those. And again, the way these objects collaborate is that there's usually one widget factory created in the entire system. Because here again, if you're on a Mac, you don't need to create the motif widget, so why even bother creating the factory? It won't work anyway. It's not what you want. And so usually there's just one of those created, but the client doesn't care because it's just given the one and only one, but it programs to the interface. It just deals with the abstract widget factory. And so what this does is it gives you good code isolation. It makes it easy to add new product families. It makes it, because all you're doing is just providing another implementation of the factory and all of the abstract products. And it makes sure that you don't accidentally mix mix your products, so that the motif. So it's the factory that controls all this stuff. So you're not going to end up with a Mac scroll bar on Windows. But it does mean, so a consequence is that if you have a new platform, it's got to support the entire interface. It's got to provide all of that stuff. So if you have, if you encounter a new, if you encounter like a crazy new platform, like maybe on, I don't know, a phone or maybe some sort of, touchscreen or something like that, you're not going to have the same widgets, or you may have more widgets, and so then you need to figure out how you represent this in your model. So, I mean, there are consequences there. Okay, that was the first pattern. Is this what you're looking for? Does this sort of make sense? Yeah, so far? Okay, cool. Okay, yeah?
So just so I can understand, you client within instantiate what?
The client doesn't instantiate. It's more like the client is handed it. So if you're interested in exploring object orientation, I highly recommend the dependency injection lecture. That is sort of like the next phase in all of this. So after these design patterns came out, then inversion of control and dependency injection became popular. People understood that. That's another very important design pattern. And what that does is that that says, hey, listen, I'm a client, and I depend on a widget factory. So, but I don't create the widget factory. Instead, I am handed the widget factory when I'm constructed, right? So the whole idea is that the dependencies, again, it's not the client doesn't know, the client doesn't care. It's that the thing that creates the client to say, oh yeah, right, you're running on Windows. Here's the Windows widget factory. Yeah, and here again is so even though it has one of these, it doesn't create one of those. Yep. Fun. I'm going to talk about this in a long time. Okay. Another pattern, builder. Let's say you've got some complex object, and it's got all sorts of fields and stuff like that. What the builder pattern allows you to do is to separate the construction of that complex object from the way it's actually represented. And so what it allows you to do is have the same construction process create different types of representations. So again, it's very similar to the factory method in that you've got you've got a hierarchy of different choices here for different, in this case, a converter, and it's up to it's up to some client of that hierarchy to interact with it. So let's say that we've got a process that takes an RTF file, again, the 90s, and converts it into one of several outputs. You can convert it to plain text. You can, you can convert it to LaTeX, or maybe there's a text widget. You're rendering it in a UI. Actually, you've seen things like, well, perhaps you've seen things like this. I'll ask you guys. So you, in your pretty printer, your pretty printer can print to standard output or to a file. How did you implement that? How did you represent that?
For mine, when creating a 3D printer, if the file name pass in was just a dash, I just set a flag to print to the screen so it doesn't the file.
Okay. Okay.
I mean, in a different step based on what that flag was, it would do the only parts that were varied from implementation to the other.
Okay. Thinking about your project 4. What is the output? Where is the pretty print output written in project 4? Where's it written?
Screen? I don't
No. What? Yes, it's in memory, but it does leave the VM. How does it leave the VM? It's written to the client. How does it get to the client? From the servlet response, right? So you remember, like in my thing, when I did the pretty print, I did a pretty. Okay, so I wrote to this response. So now, considering that implementation that you wrote in project 3, how are you going to make that right to the right to the servlet response? You've got to go into your pretty printer and say, well, let's say, hey, I got a Boolean that says whether or not you write to standard out. Okay, what, now I need to have like another option to it to say, oh no, instead write to the request? Coupling, right? Now you put the smarts, you put the logic for, here's how to choose the destination, you put it inside the pretty printer. And now what if you want to write to a socket? Or now what if you want to write to a database? Oh, crap, you got to put all that logic in there. And now all of a sudden, your pretty printer, which should just be good at like making things pretty, now needs to know where to send it, where the destination is. So, instead, what if you could abstract out the destination? Abstract out the destination so that your pretty printer can focus on what it's good at, which is formatting dates and this turning stuff into text and putting, I don't know, tabs or spaces or whatever. Put all that in their text. Well, you can do that by abstracting out what the destination is. Now, if you go back to the core API lectures where we learned about the I/O classes, right? There was like the readers and the writers and the input streams and the output streams, all those different kind of input streams and output streams. Some of the things I emphasized in that lecture is leveraging this abstraction. So if I were to implement the pretty printer, what I would do is I would have the pretty printer take one constructor, have one constructor, and that constructor be provided with a print writer. And you guys know what a print writer is? A print writer it's a class-written interface, but it's an abstraction over something, basically a text destination, and you've got a print line method, right? So it's got methods like print some text someplace. Oh, print some text, then print a line of text. Great, but that's all it does. It doesn't say anything about the destination itself, right? All this object knows is how to print stuff. And for your pretty printer, that's all you need, right? Oh, yes, print some stuff somewhere. It doesn't matter. Now, print writers take advantage of object composition, and so you can create a print writer around other objects, like a file writer. Oh, okay, cool, right. So you create a file writer, you create a file, you wrap a file writer around that, you write a print writer around that. Now you've got a print writer, you send that print writer to your pretty printer. Pretty printer doesn't care where it's going. It says, oh yeah, print line, poof, and it goes to a file. You can use that same abstraction with standard output. Right? You take your system.out, you wrap a output stream writer around it. You wrap a print writer around that, and give it to your print writer. Give it to your pretty printer. Pretty printer does exactly the same thing, same abstraction. With HTTP servlet requests, there's a method called getWriter that returns a print writer. Poof, you got one. You send it there. You don't know what's happening. I mean, actually, under the covers, it's being written to some buffer in memory that then gets sent back to the to the client. You don't care. I didn't mean to. I didn't want to make you feel bad, but this is the lesson here, right? You're reusing code, right? Yeah, you're reusing code, and this is how you make code reusable. So, at what point? And this is a question that we as software engineers need to answer: is at what point do you refactor things to make them abstract? So here again, for projects 2 and 3, for project 3, you were able to get away with, okay, yeah, my code was all right, sort of having a flag that said, do I print to standard output or do I print to the file? But now, it's like, crap, what's worse? Abstracting out the destination and then having it be passed in, or what's worse? What is more readable? What is more extensible, right? You're balancing various things. What is better, what is worse? To have specific things, to have sort of specific logic there to control the destination, or to delegate the responsibility of where the destination is off to somebody else. So, similarly,
So in this design, the print printer would take a print writer that you basically built up somewhere else. In project 4, that would be
On yes, it would be the servlet because that's where the pretty printer is created or is used. It's on this in the servlet. Yes.
So you pull out the creation of the print writer into some encapsulated.
Yeah. Well, in the case of the servlet, you get the print writer directly from the HTTP request. Sorry, HTTP response. There is a get writer method on response. Yep. Actually, shoot, I could show it to you. Where's our old friend servlet? There we go. Right here. Okay, here's write pretty printer. So, oops, sorry, I messed that up. So let's do it. Yeah, but here's what I want to show you. Pretty printer. It's not a pretty printer. Anyway. Pretty printer. Oh, I've already got. No, that's not it. Oh, I've got. Oh, actually, okay. But that's not what I want. Sorry. Okay. I need to make a new class over here. Implements phone bill dumper. Oops. Phone bill dumper, right? And this is of phone bill. So this is how I would encapsulate the pretty printer functionality into a class. So I have my pretty printer. When I create it, I just give it some writer, right? So here's the print writer I get from the response. I could also create a writer from a new print writer, create around a new file writer, create around a new file, which is whatever was passing from the command line, right? So it's bill.txt, right?
So your pretty printer class, no knowledge of Varsity.
Exactly, and that's the whole idea of the abstraction. Does at the end of the day, does the pretty printer really care where it's writing to? No, it doesn't. And this makes your pretty printer so much simpler. And that's okay, right? This is object decomposition. This is separation of responsibilities, and this is okay, and this is a good thing when it serves a purpose. And here the purpose is it allows you to use the same pretty printing functionality to multiple destinations. EA design patterns. So let's see here. Introduce a pretty printer class that abstract that doesn't know or care about the destination of its prettiness. Yep, whatever. So back to the builder pattern here. So let's say here again we've got like this converter that takes an RTF document and parses it. And okay, so think about here again. Think about a rich document. So it's got bolded sections and it's got paragraphs and it's got I guess if we were writing this in 1998, it would be an HTML document that you're rendering. Okay, RTF, whatever. And so the RTF parser knows about concepts like, oh, I just saw a character. Oh, I saw a change in the font. I just saw a new paragraph. And so it gathers all that information, and then it delegates off to some other object to actually do something with that. So here again, the parser, just like your parser has the smarts to read the file, and and then it tells somebody else. Then it says, "Okay, great. I'm seeing all this stuff going by. You handle it. You decide what to do with it." And so it just delegates off to this abstract class, which is text converter. So I don't know. Take some text and do something with it. I don't care. Seriously, I don't care. It's up to you, the text converter, to decide what to do with it. And so then you can have multiple implementations of the text converter. You get one that converts it to ASCII, another one converts it to LaTeX, the other one converts it to some widget that's displayed right there in like a WYSIWYG editor. Another thing from the 90s. But anyway, you've abstracted all this stuff out. So the RTF parser is good at RTF, great, and the ASCII converter is good at ASCII, and they're separate. Right? And again, it's up to the thing that creates this RTF parser to say, oh yeah, parse RTF, and by the way, here's the converter that I want you to use. So it'll be handed at runtime. Sure, it's an ASCII converter, but compile time, it doesn't care. It's just some kind of text converter. So again, leveraging object decomposition, leveraging class hierarchies and inheritance, and leveraging programming to the interface, this contract between the parser and the converter, the builder pattern, to do all of this. So, when is this applicable? When you've got complexity where you want to have, functionalities distributed over two places, and also when you want to have different ways of consuming or different ways of constructing, some object or something. So we talked about, the builder, the concrete builder, again, the director, and the product in this case. They've got names for it, but I think you can look at the class hierarchy and understand it. How are things used? Yeah, I mean, this is okay. Okay. This is interesting. This is okay. This is sort of like another thing on top of it. You can have another participant. So it's like, hey. So the client here is like, I want an RTF file converted into an ASCII file. And so it's the thing that will create the concrete builder, the ASCII builder, the ASCII, whatever the heck it was. I'll create the director, I'll create the RTF parser, but then I'll delegate responsibility for doing that off to the director. So I'll call like a construct method, which is like, hey, go do your thing. And the director's like, okay, I'll build part A, I'll build part B, I'll parse this, I'll do all this stuff, great. And then finally, the client says, okay, hey, concrete builder, tell me the thing you built. Give me that ASCII file that you just built. So anyway, here's another way of looking at those interactions with, no, not flowcharts. What are those things called? Interaction chart? I can't remember. So, what are some of the consequences? You can now, vary how things are represented internally, and really really isolate the responsibility for constructing some object. And here again, you have this nice separation of responsibilities between the client and then the builder. So there's an interesting relationship between abstract factory, the first pattern that we saw, and the builder pattern. So the abstract factory pattern is all about, you've got a family of different things. You're creating lots of different kinds of widgets, but they're all for the Mac. The builder also creates things, but the builder is all about representing a complex build process with multiple steps. So here again, you've got multiple steps to take that RTF document and create a text document out of it, et cetera, et cetera. Is the fat lady singing?
Yeah.
Yeah. Okay. I'm getting tired. One more, and then it'll be time for bed. Okay. Factory method. Here again, it's very similar. So now you've got an interface for creating some object. So it's a lot like abstract factory, but instead you've got a method that then sort of delegates off to some other object for doing it. Okay, so in this case, in a factory, it's a subclass that determines what to instantiate, and then you've got a superclass that exposes the fact that an object is created. Is created. So let's say that we have a UI application that displays multiple documents to the user, and so you've got an application, and it has a bunch of documents. But this application can create multiple kinds of documents. You've got multiple kinds of applications that can create multiple kinds of documents. So you've got an application that creates drawings, and you've got and that drawing creates a drawing document, and maybe you have a spreadsheet application that creates spreadsheet documents, stuff like that. The application itself knows that it must create certain kinds of documents, but there's all sorts of common code that is independent of a particular type of document that's created. So, for instance, every document has something like a save method, and the application just wants to say, "Hey, go and save the document." The application itself doesn't necessarily care what kind of document is being saved, but it does care what kind of document is created. So, when it comes to the application, it doesn't know what kind of document to create, and instead, what we do is we defer that functionality to a subclass of the application. That's depicted here in this diagram. So you have an application. An application consists of 0 or more documents. And so these are sort of the abstract things in the class hierarchy. So an application knows how to open a document, knows how to make a new document, but what it doesn't know exactly is how to create the document. As a matter of fact, its new document method goes and calls create document, and then it adds it to the list of documents, and then it opens it. That's all common. Every document to do that. But when actually it comes to creating it, it says, I don't know how to create the specific kind of document. I'm going to delegate that to a subclass. And so in this case, we have a drawing application that creates a drawing document. And then we have our abstract document and a concrete drawing document after that. It's in the same vein, right? Where you've got some abstract classes that have a relationship, and then you've got some concrete subclasses that provide the rest of the functionality. There's a whole bunch of common functionality, and then there's specific things that are delegated off to subclasses. So this is a factory method, and the fact that you've got a method which actually does the creation, that makes it a factory method as opposed to an abstract factory class. So use this pattern when you've got a class that doesn't know what kind of object to create. Or you've got a class where it's like, I have a lot of functionality, but at the end of the day, I need to delegate some of it off to a subclass, and so I have an abstract method in Java, which we must have seen something like this in your code, right? Don't I do dumb stuff like this? Well, like abstract phone bill, right? Or abstract mail.
There is some abstract.
Yeah.
There's a little part that can tell you.
Right. And I think my examples are kind of contrived, but it's meant to teach you this kind of stuff. So anyway, again, you've got participants in this pattern. You've got the products, you've got the creators, and again, you've got these parallel class hierarchies with lots of abstract stuff at the top and then specific functionality down at the bottom. And so this allows you to write a lot, again, just like these other patterns, you've got a lot of code that works at the abstract level. It doesn't need to create specific classes in the code. Instead, it sort of deals with their interfaces. And it allows new subclasses to be added. And again, you have these parallel class hierarchies. And there's a relationship between abstract factory and factory methods. Where again, like instead of having a class hierarchy, which again is like a compile time concept, you can also have this functionality being delegated off to a factory object, which is then passed into the application. So these things are related. Okay. I could go on. I think we've had enough, though, for tonight. So the slides are up there. The book itself, I don't know how well it's aged. I haven't gone back and looked at this stuff, obviously, in many years. But if you, I think in many ways it kind of is a seminal work in object-oriented programming. And if you find yourself, doing this kind of stuff professionally, and if you find yourself in an environment where you really want to, dig into frameworks or write frameworks for your own, there's a lot of good stuff here. So, anyway.
There's two guys where I work that are full-time going through all the legacy stuff, looking for patterns.
Yep. Yeah, and a lot of refactoring. And so actually there's a Michael's Feathers book on the legacy. Oh shoot, what's the name of it? It's the legacy software. It's a really good book. Lots of people have this problem, and there have been a couple of authors that have really talked with a lot of people and have understood, hey, what does it mean to have legacy code? And oh my gosh, how do you even begin to approach a code base which is millions of lines long, which is decades old? Even Java code now is decades old, right? It's not the language's fault. It's the fact that, hey, you've got a system that's been successful enough that has lived for 20 years. So legacy code isn't bad. There must be something good there because we're still using it, right? So I approach legacy code with a tender appreciation, but I want to make it better. Right? It's legacy because it's valuable, but we've learned a lot, and there are new tools, there are new techniques, so we need to figure out, great, how can we improve it while still making sure it provides the same value? And it's a challenge, it's really hard, but boy, it's really valuable when you've got something that's providing value today and you want to be able to provide more of it. If you can figure out how to leverage that investment and therefore have something cheaper, because I'm sorry, it's always more expensive to rewrite it. So anyway, enough of that. Have a great evening, everybody. Have a great week. Let me know how things go with Project 4. I've tried to prepare you as best I can. You've seen lots of examples. Go ahead and try it, but it's certainly challenging. Looking forward to next week when we talk about Project 5.